Hey there, fellow physics studentos. Next we're going to be working on the soccer shot simple problem. And in this problem we are given the velocity initial of the ball, the theta angle, the height of the target, and we want to find the maximum distance that we can be from the goal while having the ball reach the net at the height of the target. And so let's go ahead and jump in. Got a fun little picture here of a rocket, just, because of rockets. Maybe we'll add a couple stars. Anywho, I'm getting ahead of myself. This is not an art video, this is a physics video. So I have here laid out the variables that we're going to be solving and the variables that were given, and we're going to go ahead and jump right in and get started. So the first thing that we want to do to ultimately find the range is we want to find the separate velocity vectors, the velocity in the y and the velocity in the x. This is because of the equations that we're going to further plug them into. So let's go ahead and do this thing. So the velocity in the y direction is going to be equal to the initial velocity times the sine of theta. And this is going to equal 11.6 times the sine of 40.7 degrees. And if we plug that into our calculator and churn it out, we're going to get that the velocity in the y is equal to 7.6 meters per second. And we're going to do the same for the velocity in the x. That's a little bit different though. We're running out of space here. So for the velocity in the x direction, it is v velocity initial times cosine of theta. And that's going to be 11.6 times, oops, not sine, cosine of 40.7. And if we plug that into our calculator, we're going to find that the velocity in the x direction is equal to 8.79 meters per second. Okay, so let's box up these answers and move on to the other fun stuff in this problem. So now that we have the velocity in the y, you might be wondering what we're going to be doing with that. Well, we have to find the second time that the ball is going to be traveling when it reaches the target. So we're going to be using the h equals velocity in the y times t plus 1/2 at squared formula, and plug in what we know and solve for what we don't. So 0.938 equals the velocity in the y, which is 7.6 times t. And then I forgot to mention, the acceleration here is going to be just like on our planet, negative 10 meters per second squared. And we want it to be negative because we're finding a velocity and we have to know the downward direction. So minus 5 times t squared, because 1/2 of negative 10 is negative 5. And we're going to subtract 0.938 from both sides because we're setting up for a quadratic formula equation. So this is going to equal 0 equals negative 5 times t squared plus 7.6 times t minus 0.938. And if we get the general form of the quadratic formula, we're going to get that the time is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And forgot to mention that we should point out the variables here. So the a is going to be negative 5 right here, b is going to be 7.6, and c is negative 0.938. And if we plug that in, we're going to get that this is negative 7.6 over negative 10 plus or minus the square root of 7.6 squared minus 4 times negative 5 times negative 0.938. Sorry, I ran out of space there on my other screen. You get the gist, I hope. Yeah, square root of 7.6 squared minus, let me write really small here, negative 4 times negative 5 times negative 0.9. Oh, alright, divided by 2 times negative 5, which is just negative 10. Getting a little behind myself here. And if we turn this out, we'll get the 2 times. I have a little app on my calculator that helps me solve the quadratic formula, so it saves me some time here. So let me just plug these numbers in. And on my calculator, I got the times are 0.14 and 1.4 seconds each. And we're going to focus on this second time here, because that's what we're going to plug in for our final equation, home stretch. We're going to use the r equals vx times t equation, because we're solving for the range. And this is going to be equal to the velocity in the x, which we calculated earlier, 8.79, times the second t, 1.4, and that will equal 8.79 times 1.4, 12.31 meters. And there we go. Oops. Scrolling up here. So there we go. We found our range. And let's go ahead and plug it into the website and see how we did. So enter your name and 12.31 as our distance. Alright, so the distance was 12.4, our response was 12.31. We are in the range, hence the good work notification here. And so hopefully this tutorial was helpful in some way. Feel free to email me any questions you have for this example problem, and I'll see you on the next one.